Solve for x. Okay. Root 3 raised to 3x minus 4 is equal to 3 root 27 the whole raised to x. Got it, Peter? Now when you look at it, root a is nothing but a to the power half. Root x is nothing but x to the power half. So here, root 3 will be nothing but 3 raised to half. I hope you are getting here. So that means on the left hand side, I'm going to simplify. So what I do is this root. Okay, what does it mean? It means 3 raised to half, the whole raised to 3x minus 4 is equal to. Okay, on the right hand side also I can simplify 3 and what is this? 27 raised to half, the whole raised to x. Okay. Again, we are going to simplify. Remember, children, whenever you see a raised to m, the whole raised to n, correct? It is a raised to m into n, correct? So naturally, here what will happen? 3 into half into 3x minus 4. It will become 3x minus 4, the whole raised to half, okay? And here what will happen? Here still more to be simplified. You can see here, children, this is 3 into 27 raised to half. This is nothing but 3 raised to 3, the whole raised to half. So 27 can be written as, okay, 3 raised to 3, the whole raised to half, raised to x, okay? Again, children, 3 raised to 3x minus 4, the whole upon 2. On the right hand side, again, 3 into 3 raised to 3 into 1 upon 2 is 3 upon 2. The whole raised to x. Again, children, remember, whenever you have, this is 3 raised to 3x minus 4, the whole raised to 2. And here what will happen? 3 into 3 is nothing but 3 to the power 1 into 3 raised to 3. 3 to the power 3 by 2. What will happen, children? 3 by 3 raised to 1 plus 3 by 2. The whole raised to x. Still, this left hand side has got simplified long time back, so I think it as it is, okay? But the right hand side I think is still simplified. So what will happen here? 1 plus 3 upon 2, cross multiply. Okay, 2 ones are 2, 2 plus 3, the whole raised to 2 plus 3, the whole raised to 2, the whole raised to x. Okay, children? Now what will happen, children? Again, further. You can see here, I'm going to simplify further, children. I'll just rub this off what I've written as reason to make you understand, okay? So now what will happen, children? You can see here, on the left hand side, raise 3 raised to 3x minus 4 as it is 3x minus 4, the whole raised to 2 is equal to, on the right hand side, what is, this will become 5 upon 2, 3 to the power 5 upon 2, the whole raised to x. So this will become 3 to the power 5x upon 2. Now you can see here, these two are equal, the indices are equal, the bases are same. So naturally the power should be also equal. So 3x minus 4, the whole raised to 2 is equal to 5x upon 2. Now this 2 and 2 will get cancelled. 3x minus 4 is equal to 5x. So what will happen, children? Minus 4 is equal to 5x minus 3x. I bring 3x on this side. Minus 4 is equal to 2x. So this 2 is multiplied with x. So it will come down. Minus 4 by 2 is equal to x. So x is equal to minus 2. Okay, look like a very small sum, but I hope people understood this. Quite an easy one. Okay, I don't think it's difficult. You should have patience. Question number 8, children. Find x. If root of 6 to the power 0 plus 1 upon 3 is equal to 0.75, the whole raised to 2x minus 3. So how are we going to go about? Children, find x. Similar to the previous sum. Okay. So what am I going to do? Children, we have to, okay, I'll first write the question as this. Root of 6 to the power 0 plus 1 by 3 is equal to 0.75, the whole raised to 2x minus 3. So I want the answer in the power. You know, the x exists in the power. So naturally, bases should be tried to make equal. The bases are equal, the parts can be equal, okay? So that is the hint of this sum, okay? Because the value of x comes in the part, so I should take care the bases become the same. So when I look at the left hand side, I'll start somewhere. Any number raised to 0 is 1. So this, if you look at it, this is nothing but 1 root of 1 plus 1 by 3 equal, here also simplify 75 upon 100. The whole raised to 2x minus 3. Here what will happen? This will become root of 3 plus 1, 4. 4 upon 3 is equal to, this is 25 3s are 25 4s are. So this becomes 3 upon 4, the whole raised to 2x minus 3. Now when I look at this is nothing but 4 upon 3 raised to half is equal to, they're giving you like this, 3 upon 4 raised to 2x minus 3. Now look at the bases. The bases are reciprocal. They're not some equal, but can you make them equal? Yes, you can easily make them equal. Okay, children. Now how do you make them equal, children? Now when you look at the base, children, the base is 4 upon 3 and 3 upon 3. Yeah. If I make it, you can see here, children, the base here is, on the left hand side, the base is 4 upon 3. On the right hand side, the base is 3 upon 4. Bases, if the bases are equal, then only equate the index. Because the x is there in the index. Okay. So what I should do, how can I make the bases equal? Yes, I can easily make the bases equal. Your choice, okay? Either left hand side you make the base 4 upon 3, or on the right hand side you make the base 4 upon 3. Suppose 4 upon 3 as it is raised to half, okay? On the left, right hand side, just the right hand side. If I make the base 4 upon 3, it was 3 upon 4, I made it 4 upon 3. So what I should do, I should just change the sign of the power. Power was plus bracket 2x minus 3. So minus 2x minus 3. Minus of 2x minus 3. Now the bases are same. So naturally I can equate the index. So what will happen, children? I equate the index. So what will happen? Therefore half equal, you can see here, half equal, therefore half equal minus of 2x minus 3. So I'm equating the index, got it? So now what will happen? Very simple sum, okay? You can really see half equal, change the sign, minus 2x plus 3, minus sign goes inside, minus 2x, minus into minus plus. Now you can see minus 2x, I bring it this side, 2x, and 3 plus half, I bring it on this side, minus half. Okay, when you solve it, 2x equals the LCM, you can see here 2 3s are 6, 6 minus 1 upon 2. So 2x equals, this will become 5 upon 2. So x equals 5 upon, this 2 will come down, 5 upon 2 into 2, the 2 comes down. So what is x equal? 5 by 4, 5 by 4. So I hope people have understood me here. Got it? What is the biggest hint I told you? I want to find x, and x is lying on the power. The index consists of this x. X term is there in the index. So whenever the x term is there in the index, remember only one method. You have to make the bases of left hand side and right hand side same. So if the bases are same, generally it will equate the index. Okay, so we go to the next one, children. Very simple question. Question number 9. Now, question number 9, the first part of it, 3 squared, so into 4 to the power 0 plus 5 to the power 3x equal 9 by 25. Again, you can see solve, find the value of x. Where is x? X is in the power. When x is in the index, in the previous time I told you, on either side, you should try to make the bases same. If you make the bases same on either side, if you try to make the bases same on either side, then perhaps you can get the value of x. Not perhaps, you will get the value of x. If the base are same, you can equate the index and try to find the value of x. So here, let's see here. This is 3 squared, am I right? 3 squared is nothing but 9. Okay, 100, okay? 4 to the power 0 is 1 plus 5 to the power 3x. okay, is equal to 25 9s are. 25 is the 200, 25 and 225, this 225 plus 9, 234 upon 25. Now what will happen? So 9 months are 9 gets distributed inside. 9 ones are 9 plus 9 into 5 to the power 3 is equal to what will happen? 234 upon 25. Now this plus 9 will go on the other side. So 9 into 5 to the power 3 is equal to 234 upon 25 minus 9. Now what is the LCM here? So 9 into 2 to the 5 to the power 3x is equal to. Now what will happen, children, here? This is 25 LCM. 1 into 234. 234 minus 9 into 225, 225. Okay, 25 is the 200, so 225. Now what will happen, children? 9 into 5 to the power 3x is equal to 234 minus 9, 9 upon 25. Now, you know one thing, this 9 is multiplied with this. So the 9 will come down, children. What will happen, children? You can see here, this 5 to the power 3x, 5 to the power 3x, and the 9 comes down is equal to 9 upon 25 into 9. Oh, this 9 and 9 get cancelled. So 5 to the power 3x equals 1 upon 25. Children, you have to find the value of x, okay? The power is 3x. Power is 3x. So what I do, 5 to the power 3x is equal to 5 to the power minus 2. Now you can see the bases are same, so the index are equal. Therefore, 3x equals minus 2. So x equals minus 2 by 3. Correct? So I just found out the value of x. Okay, children. I hope people have found it easy. Children, not difficult. I don't think it's difficult. Okay, it's quite easy stuff. Now look at the sum, children, and the previous sum. What is the difference between these two questions? Here, the x term is not in the power. Okay, x is in the base. X is in the base. X is in the base of this number. I hope people are getting me here. So the whole thing, please have a look here. Now what you should do? The powers you should try to make is, please have a look here. X raised to 2 by 3 equal, what is this? 3 square. Okay. Now listen, this is 3 square. Okay, 3 square. Now all of it pay attention here. The base is x minus 1. The power is 2 by 3. If the power is 2 by 3, I cannot solve it. So what I do, I want this power to become 1. The power will become 1 only when I multiply this power by 3 by 2. If I multiply the power by 3 by 2 here, even on the right hand side, you should multiply the power by 3 by 2. I hope everybody understands what I've done here. I want x minus 1 the whole raised to 2 by 3. X is present in the base. Alright. So how to go about? So can I make this power of this base x? Okay, can I make it as 1? Yeah, if I multiply by the reciprocal 2 by 3 का reciprocal 3 by 2 है. तो दोनों साइड 3 by 2 से मल्टीप्लाई किया तो ये हो गया x to the power x minus 1 the whole raised to 1. Got it? And here what 2 gets cancelled and this becomes 3 cubed. So what happens? X minus 1 is equal to 27. So what is x equal? 27 plus 1 to make this very simple sum. X equals 8. X equals 8. A very important sum, children. Very nice question, children. I hope you'll make a notice of this. Try to solve it once again. Okay? Now look at this question 11. Express with a single index. Express it with a single index. Means you want one number to the raised to something. Okay? Not like you have 2 raised to 30 plus 2 raised to 30. So what happens, children, when you look at it, anybody can understand. Okay? So 2 raised to 30 I will common. I'll tell you. So what will happen? Okay, I'll just write once again. I'm so sorry. I better write a solution and rewrite the question. Okay, so that everybody can understand. 2 raised to 30 plus 2 raised to 30. I want it as a single index. So what I do, 2 raised to 30 is common. तो इधर 2 raised to 30 की जगह में 1 बच गया बेटा, इधर भी 2 raised to 30 बाहर गया तो इसकी जगह में 1 बच गया. So this becomes 2 raised to 30 into 2. 1 plus 1 is 2. Oh, I want common single index, okay? So, whenever it's a raised to m into a raised to n, okay, this 2 is nothing but 2 to the power 1. So naturally, this will become 2 to the power 30 plus 1. But what will happen 2 to the power 31? So I express this as a single index, okay? I express it as a single index. You can expect a 2-mark question, okay, of this type, children. Then we go to the next question, children. A simple question. Question is, find out if a to the power 20 plus a to the power 20 equal to the power n. A very simple sum, children. Many of the children will just leave it. Children, just now we saw one sum earlier. Write it as a single index. So I'm going to write that. First, I'll rewrite the question. A to the power 20 plus a to the power 20 is equal to 2 to the power x. Okay? See, one thing I have told you, the power x value, I want the x. X is in the power. X is in the power. That means you should try to make the bases same. You should try to make the bases same. And I think I can easily make the bases same. First, what I'm going to do, a to the power 20 common. So in place of this first a to the power 21 will remain. In place of the second, there also 1 will remain, equal to the power x. So a to the power 20 into 2 is equal to the power x. Now, listen, can I make the bases in here? Easy. 8 can be written as 2 to the power 3, the whole raised to 20, into 2 to the power 1 is equal to the power x. Now, what will happen? This is 2 to the power 60 into 2 to the power 1 is equal to 2 to the power x. The 2 to the power, a raised to m into a raised to n is a raised to m plus n. So 2 to the power 60 into 2 to the power 1 is 2 raised to 60 plus 1 is equal to 2 to the power x. So this is 2 to the power 61 is equal to 2 to the power x. So what I get, children, very simple. I hope you must have got an answer by now, okay? What is that? 2 to the power x, 61 equal to the power x. Bases are same. So what will happen to the index, children? The index, therefore, when the bases are same, I can equate the index. Therefore, x equals 61. I hope people understood me here. A very simple sum, okay? People should do it. We go to the next sum, children. Question number 38. Question number 38. What is that? Show that now this question, just have a look at this, okay? Very important something. Question number 13, children. Show that root of a to the power x root xy, okay, I mean third root, now xy root of a to the power x upon a to the power y, yz root of a to the power y upon a to the power z, zx root of a to the power z upon a to the power x. So what does it mean, children? So I want to prove this is into all this into, okay, into equal 1. So I start with the left hand side solution. Children, it's very easy sum. Just try to understand, okay? What I do, I first rewrite the question. Left hand side is what? Okay, xy root of, okay, xy root of xy root of a to the power x upon a to the power y. I'm rewriting, please come with here. I'm rewriting this left hand side, okay? The second term is what, children? You can see here, it is yz root of what you can see here, a to the power y upon a to the power z, and then, children, into, again, what is it? zx root of zx, okay? What is this zx? The zx root of, you can see here, a to the power z upon a to the power x. So now what I'm going to do, children, I'm going to write this as left hand side, okay? Here, a to the power x upon e to the power y into xy. Got it? Into e to the power y upon e to the power z into yz, into yz, into e to the power z upon e to the power x. So whole raised to zx. Got it? Is equal to, if you ask me, what will happen here, children? E to the power x minus y, the whole raised to xy, into e raised to y minus z, the whole raised to yz, into e raised to z minus x, the whole raised to zx. Now what will happen, children? A raised to m, the whole raised to n, you'll have to multiply. So what will happen? A to the power xy into x minus y, into e to the power, into e to the power yz, e to the power yz, y minus z, yz, into y minus z, into e to the power zx, into z minus x. So what will happen, children? Just have a look at the left hand side. Now open the brackets, okay? So what will happen, children? E to the power, here, e to the power, this will become first xy into x. Xy into x is x squared y minus xy into 1 minus xy squared into e to the power yz into 1 y squared z minus yz squared minus yz squared into e to the power zx into zx, z squared x minus zx squared. Now all to the base same a. So the powers will get added up, children. So it will become e to the power x squared y minus xy squared minus y squared z plus yz squared plus this is z squared x is nothing but xz squared minus x squared z. And now when you look at it, children, x squared y, now you can see what else is given. Nothing else. Any other thing is given? No. So now just think about it, children, how we will go about, okay? So what has happened? Xy squared. Anywhere else x to y squared is there? No. Y squared is z, x squared is z. Okay? So actually, children, what will happen here is I'm so sorry, children. I did a mistake with the sound. I'm so sorry. Again, when xy is the root of a to the power x upon it. So a to the power x upon e to the power y, the whole raised to, it should be 1 by 1 upon xy. Here it should be 1 upon yz. Here it should be 1 upon, oh, I'm so sorry, children. I'm so sorry. Okay. So what will happen here? All this multiplication, when you look at it. Here, what will happen to this, children? A to the power x minus y is okay into 1 upon xy. Here, a to the power y minus z, okay, into 1 upon yz. And here, z minus a to the power z minus x into 1 upon zx, okay? Now what will happen, children? Everybody can understand. Here, it is like, it will become, children, a to the power x minus y, the whole thing upon xy, into a to the power y minus z upon yz, into a to the power z minus x upon zx. So what will happen to this is, children, okay, when you do it, equal a to the power x minus y upon xy plus y minus z upon yz plus z minus x upon zx equal a to the power LCM is xyz. So here xy is there, z is missing. So xy I'll have to multiply by z to make it xyz. So on top I should multiply by z into x minus y. Here yz is there. What is missing? X is missing. So to make it xyz I'll have to multiply this yz by x. So ऊपर का भी x से multiply करने का, x into y minus z plus here zx. What is missing? Y. So naturally इसको zx को y से multiply by xyz, तो ऊपर भी y से multiply करने का, y into z minus x. Now what will happen? So a to the power xz minus yz plus xy minus xz plus yz minus xy. Now when you look at it, xz minus xz 0 minus yz plus yz 0, xy minus xy 0. So ultimately I got a to the power 0, which is any number a to 0 is 1. This is your RHS. We started the left hand side, became RHS. Sorry, my small mistake I done here. Not a small mistake, big mistake. Okay. No, I'm not saying, okay, such mistake should not happen. Okay, just an oversight. Okay, so when we go to the next sum, question number 14, children, very important sum is x to the power a equal y to the power b equal z to the power c. And x, y, z, x into y into z is 1. Find the value of 1 upon e plus 1 upon b plus 1 upon c. Always remember, children, whenever you come across a body, whatever follows if e is given to you, you have to use these things. X to the power a equal y to the power b equal z to the power c. These three things that you use, and x into y into z equal 1. You have to use this, and then with the help of it, find the value of 1 upon a plus 1 upon b plus 1 upon c. So see how I go about, children. All these three are equal. Okay. So just now I have taught you something, and in the previous term we'll be using that idea. See, first thing what I will say is, let x to the power a is equal to y to the power b is equal to z to the power c. All these are equal given to us. So what I do, let x to the power a is equal to y to the power b is equal to z to the power c is equal to k. Now listen, can I say this alone, one at a time, okay? X to the power a is equal to k. Got it? So if I want to make this power as 1, x to the power 8, but I want x to the power 1. I want x to the power 1. I want this 8 to become 1. So naturally, what I'll have to do, I'll have to multiply by its reciprocal 1 upon 8. If I do here multiply by 1 upon 8, the power, here also I should multiply by 1 upon 8. So here, what will happen? X gets cancelled. So a gets cancelled to the x to the power 1 is equal to k to the power 1 by 8. I call this as 1. Okay. In the same way, children, now, when you look at it, okay, we go to that next one. What is that? Y to the power b. Y to the power b is equal to k. So I want y to the power 1. I want y. I want this as y. So naturally, I multiply the power by 1 upon b. So b into 1 upon b can become 1 or not. So even on the right hand side, I do k to the power 1 upon b. So this b and b will get cancelled, children. And what left is y. Y is equal to k into 1 upon b. And this is your equation number 2. In the same way, children, I can say z to the power c is equal to k. I want it as z to the power 1. See, z to the power c है, तो क्या करना पड़ेगा बेटा? c को 1 upon c से multiply करूंगा इधर पावर को. So when I do So raised to 1 by c on the left hand side, even on the right hand side, k to the power 1 by c. Here c gets cancelled. Z equals k to the power 1 by c. This is my 3. Now I told you, you made use of this part, okay? Which part? That is, the first part you made use of. X to the power a equal y to the power b equals x to the power c. With the help of them, I got the value of x, I got the value of y, I got the value of z. Now one more thing is that x, y, z is 1. So what I do, just have a look here. X to the power x into y into z, x, y, z equal 1 is given. So what I can do is, children, in place of x, what is x? K to the power 1 by a, k to the power 1 by a into y का जगह में क्या लिख सकता हूँ? K to the power 1 by b और z का जगह में k to the power 1 by c और 1 का जगह में k to the power 0. 1, any number into 0 is 1. So right hand side 1 is a k to the power 0. Now look at the left hand side. A to the power m into a to the power n. What will happen? A to the power m plus n. So all the powers, bases are same. So the powers will get added up. 1 upon a plus 1 upon b plus 1 upon c is equal to k to the power 0. The bases are same, children. The index should be equal. Therefore, 1 upon a plus 1 upon plus 1 upon c equals 0. You wanted that answer, okay? 1 upon a plus 1 upon b plus 1 upon c equals 0. I got it. The value of 1 upon a plus 1 upon b plus 1 upon c. So simple this sum is, okay, children. I hope people understand me. A very interesting question. Now I go to question number 15, children. I go to question number 15. Solve for x. We find the power 2x, 5 to the power 2x plus 3 equals 5 to the power 2x plus 1 plus 600. We'll find the value of this x. So I told you, whenever you have the variable which you want to find x in the power, in the index, then you should always do base equal base so that you can say index are equal. Are you getting here? You should make the base same. So look here, look at this expression. This is 5 to the power 2x plus 3 equals 5 to the power 2x plus 1 and plus 1 plus 600. What is 600, children? You can see here, it is 5. What you can do is, all prime factors of 600 if you try to find out. Okay, when you try to find the prime factors of 600, how much you get, children? You can see here, if I start with 5, 120 is there. 5 4s are 5 2s are 10, 24s are. Okay, so 25 into 24. I can maximum write 5 square into 24. Right? So now what will happen, children? I want people to pay attention here. So here, 5 square into 24. Everybody try to understand this. Right? Or I can also do it in a slightly different way. One bit. The first step, I'm not going to solve it. One bit. Solution, the final step I'm going to write is 5 to the power 2x plus 3 equals 5 to the power 2x plus 1 equals 600. Plus 600, sorry, plus 600. So this I'll take it on the other side. 5 to the power 2x plus 3 minus 5 to the power 2x plus 1 is equal to 600. So here, 5 to the power 2x into 5 minus 5 to the power 2x into 5 to the power 1 is equal to 600. Here, what is common, children? 5 to the power 2x is common. So 5 cubed minus 5 equals 600. So what will happen, children? When you look at it, 5 to the power 2x into 125 minus 5 is equal to 600. Okay? So what will happen? 5 to the power 2x is equal to into 100. Sorry, into 120 is equal to 600. This 120 will come down. 5 to the power 2x is equal to 600 upon 120. Oh, this 125 is down. So naturally, 5 to the power 2x is equal to 5 to the power 1. So 2x equal 1. So x equal 1 upon 2. So this is solve for x. We got the value of x. Now you find the value of 18 to the power x raised to half. So what I'll do, 18 x the whole raised to 2, 1 by 2 is equal to 18 into half. X is half. The whole raised to 1 by 2. This becomes 9 now. So this becomes 9 raised to 1 by 2. This becomes 3 squared into 1 by 2. 2 to get cancelled. What is the value of x? 3. A very simple question, children. I hope you have understood it, okay? Now I go to question number 16. Question number 16. Not a very simple sum, children. Question number 16, children. If 3 to the power minus 8, the whole raised to minus 3, 27 to the power 8, plus 729 to the power 8, upon 3 to the power 2b into 4 raised to half is equal to 3 raised to minus 8, then show that b is equal to 3a plus 4. So one thing you can see, what is the base here? 3. So on the right hand side, okay? So here also, the whole thing, left hand side, I simplify and make a common base 3. So how that we do? Let's see here. First, I write the whole thing, what is given? 3 raised to minus 8. The whole raised to minus 8 into 27 raised to 8 plus 729 raised to 8. The whole 3 raised to 2 into 4 raised to half. The whole raised 3 raised to minus 8. Very simple, children. What will happen here? This will become, the powers will get multiplied, minus a into minus 3 plus 3 into this 27. I can always try to 3 cubes the whole raised to 8. I'm simplifying it. Plus, and this 729, I can always write as 3 6 cubes to the power 6, the whole raised to 8. The whole thing upon 3 to the power 2b into 2 square, the whole raised to 1 is equal to 3 raised to minus 6. Now this will become 3 raised to 3a into 3a into 3 raised to 3a plus 3 raised to 6a. The whole thing upon 3 raised to 2b into this 2 into half. The powers get multiplied, so it becomes into 2 is equal to 3 to the power minus 8. Now again, children, you can see here on the left hand side, I think I can, what is this? 3 to the power, left hand side simplify. This will become 3 to the power 6 plus 3 to the power 6. The whole raised to 3 to the power 2b into 2 raised to 1 is equal to 3 raised to minus 8. As the whole base, I want to make it as 3 to the power something. So what will happen? This is 3 to the power 2. Okay. Now this will become 3 to the power 6 common. The whole bracket, 1 will remain, here also 1 will remain, upon 3 to the power 2b into 2 is equal to 3 raised to minus 8. Now when you look at it, 3 raised to 60 into 2 upon 3 raised to 2b into 2. I think you can clearly see your 2 gets cancelled. Now what happens here? This becomes 3 raised to 6a upon 2 raised to 3 raised to 2b. So 3 raised to 6a minus 2b is equal to 3 raised to minus 8. So now what will happen? 3 raised to, if the bases are same, bases are same. So the index we can equate, okay? So what will happen to the index then? Here it will become 6a minus 2b is equal to minus 8. Divide by 2 throughout, 3a minus b equal minus 4. So what am I going to do? I'm going to take the b on the other side. 3a minus 4 comes as plus a is equal to 3. This is what is the answer, right? Okay, I have proved it. Okay, children. Now we go to question number 17. Question number 17. Now solve for n. Children, just like solve for x, now you have to solve for n. Look, n is present in the index. So whenever the missing term, what you want to find out, is present in the index. I told you now, if bases are equal, then the parts can be equal. I have to use that idea. I have to make the same base on both sides, left hand side and right hand side. So you can very simple. What is this? 3 raised to n into 3 squared. I'm solving it, okay, children? Okay, I'll first write the question and then start solving it, okay? The solution. What am I going to do is, I'm going to solve it, okay? First step. What am I going to do? 3 raised, first copy the question, 3 raised to n into 9 raised to n plus 1. The whole thing divided by 3 raised to n minus 1 into 27 raised to n minus 1 is equal to 81. 81 is 3 raised to 4. So I know I have to make that common base 3. So what I do, 3 raised to n as it is into 3 squared. The whole raised to n plus 1. The whole divided by 3 raised to n minus 1 into 3 cubed. The whole raised to n minus 1. So now what will happen in the first bracket, 3 raised to n into, what will happen? 3 raised to 2 will get multiplied with n plus 1. So 3 to the power 2n plus 2 divided by 3 raised to n minus 1 into 3 raised to 3 into n minus 1. So whole raised to 3 to the power 4. 81 is 3 to the power 4. And here what will happen, children? The bases will get added up. 3 raised to n plus 3n minus plus 2. The whole thing divided by 3 to the power n minus 1 plus 3 into n minus 1 is equal to 3 raised to 4. Now listen, when the bases are as a raised to m divided by a raised to n, the powers get subtracted, so 3 raised to 4n plus 2 minus of n, when you open the bracket, 3 and 4n, minus 1 minus 8 minus 4. So what it is written? 3 raised to, what it will be? So when you look at it, what it will be, children? It's minus sign, okay? 3 raised to 4n, so 4n will come, minus 1 minus 2 minus 4 is equal to 3 raised to 4. So when you open the bracket, what will happen here? So this one small method, 2n, 2n. This is 3n. It will become 3n. It will become 3n. When small listed identity, here, that is what I was thinking. I was thinking about how can I get an answer here. 3 plus n plus 2n plus 2. So this will become 2n, 3n plus, ultimately this base will become 3 to the power 3n plus 2, the whole divided by, oh, I'm so sorry. The next step is, here we'll just run this, but I'll simplify it, okay? I did a mistake. Just 3 raised to 3n plus 2 minus of 4n minus 4 is equal to 3 raised to 4. When you simplify this, this will become 3 raised to 3n minus 4 is minus n plus 2 plus 4 is plus 6 is equal to 3 raised to 4. So what will happen? The bases are same. So minus n plus 6 is equal to 4. So minus n is equal to 4 minus 6. Minus n is equal to minus 2. So n is equal to 2 is the answer. Okay, so we go to question number 88. Question number 17, children. Solve for n. 3 to the power n, you can see this n is present in the past. So whenever n is present in the power, I told you children, it should always be like this, a to the power m equal a to the power n. The bases are same. I can say the index are equal. And therefore m equal n. I have used this idea to get the value of n. Are you getting me, children? So see how I go about doing this. I first simplify. Simplify means bring everything to the base of 3. So this is already 3 to the power n. And this is 9 to the power n plus 1. I can always write it as 3 squared. The whole raised to n plus 1. Now, this whole thing inside one bracket divided by, again, 3 to the power n minus 1 multiplied by this 27. I can write it as 3 cubed. The whole raised to n minus 1 is equal to 3 raised to 4. Now listen, I started solving. I should have rewritten the question, but I just started solving it. Okay, it doesn't matter. This is a question. Okay, first line is a question, and then I started. Now this is 3 raised to n, and here check 3 square. See, a raised to m, the whole raised to n, a raised to m into n. So 3 into 2 gets multiplied as n plus 1. So what will happen? 2n plus 2. 2n plus 2. 2n plus 2. Correct? 2n plus 2. The whole thing divided by, what will happen here, children? 3 raised to n minus 1 into 3 to the power 3n minus 3 equal 3 to the power 4. So now what will happen, children? 3 raised to n into 3 raised to 2n plus 2. So divided by, oh, so sorry, children, I better say here. So what will happen, children? Here, 3 raised to n into 3 raised to 2n plus 2. So here, a raised to m into a raised to n is a raised to m plus n. So this will get added, n plus 2n plus 2. The whole thing is divided by, here, everything is 3 raised to a raised to m into a raised to n is a raised to m plus n. 3 raised to n minus 1 plus 3n minus 3. The whole raised to 3 raised to 4. Now what will happen? 3 raised to 3n plus 2 divided by 3 raised to 4n minus 4, the whole raised to 3 raised to 4. Now this is division, children. So the parts get subtracted. 3n plus 2 minus 4n minus 4, the whole raised to 3 raised to 4. So now what will happen, children? Here, 3 raised to 3n plus 2 minus 4n plus 4 is equal to 3 raised to 4. So what will happen here? 3 raised to minus n plus 6 is equal to 3 raised to 4. Now bases are equal, so the index, I can equate the index. So what will happen here? Minus n plus 6 is equal to 4, children. So minus n is equal to 4 minus 6. Minus n is equal to minus 2. So n is equal to 2. So this is the answer. Children, solve for n, matlab, I got the value of the answer. Okay, children. We start with the left hand side. Children, you prove that 1 upon 1 plus x to the power a minus b plus 1 upon 1 plus x to the power b minus a equal 1. So I start with prove that on the left hand side. Well, the left hand side is 1 upon, what is it, children? 1 plus x to the power a minus b plus 1 upon, what is this? 1 plus x to the power b minus a. So what did we do? It's so simple. 1 upon 1 plus, what is this, x to the power a minus b? So much of that, x to the power a upon x to the power b. इसका मतलब है 1 upon 1 plus x to the power b upon x to the power a. Now here LCM. What will happen, children, on this denominator? Just here x to the power b plus x to the power a, the whole raised to x to the power b. And here what will happen, children? 1 upon x to the power a x to the power a plus x to the power b upon x to the power a. So what will happen here, children? X raised to b upon x raised to b plus x raised to a plus what will happen here? X raised to a upon x raised to a plus x raised to b. Now what will happen, children, here? You can clearly see the denominator is same. When the denominator is same, the numerators will get added up. So what will happen, children? Denominator x raised to b plus x raised to a. X raised to a plus x. So this is x raised to a plus x raised to b. When the numerator gets added up, x raised to b plus x raised to a. Don't you agree? When you look at it closely, this is one and the same. So naturally upon one, hey, don't agree, I got the right inside. A very simple sum, children. I hope people understood me here. Go to the next sum, children. Now, what is that simplify? What is this question? 1. This I'll take it as a base bracket. Okay, the base bracket, I'll write it, put it like a base bracket. Okay, this is 1. Okay, minus. Then this I'll take it as a square bracket, 1 minus. And this is 1 minus curl bracket. Okay, raised to minus 1. The whole raised to minus 1. The whole raised to minus. Okay, so now you see how we simplify. Okay, what am I going to do? Base bracket, this base bracket, my raised to minus, and let it be 1 minus. First, this bracket, inside this square bracket, sorry, inside this bracket, the raised to minus 1 है. So उसको नहीं, upon, इसको 1 upon 1 minus a, the whole raised to minus 1. I hope you're getting me. I opened it, okay? 1 minus a is the whole raised to minus 1 upon. Now when you simplify this, 1 minus, inside this LCM, 1 minus a minus 1 upon 1 minus a, the whole raised to minus 1, the whole raised to minus 1. When you try to 1 minus 1 gets cancelled, 0, this becomes minus a upon 1 minus a, the whole raised to minus 1, the whole raised to minus 1. So here what will happen, children, again, equal to the whole square 1 minus, I'll just 1 minus a upon, that minus into minus, this will become plus a, upon a, the whole raised to 1 now, the whole raised to minus 1. Now simplify this, what will happen, children? The base bracket, okay, raised to minus 1. So LCM is a cross multiply, a plus 1 minus a, the whole raised to a. So a minus a gets cancelled. So ultimately what I got, 1 upon a raised to minus 1. This is nothing but a raised to minus 1, the whole raised to minus 1. So ultimately a is the answer for it. When you simplify, okay, a raised to plus 1, it will become a raised to plus 1 is nothing but a. Alright, children. So if you do all these sums, rewrite all these sums, watch it, rewrite, I'm sure children this chapter looks simple for you, okay? So this I complete the Icse, this chapter is complete, okay? Maximum this type of sums will only be asked.